Doctor. Morning.
Good morning, Doctor.
Okay ke tak tu? You all okay?
Still surviving.
Okay, let me share the screen. Okay. 17, 16 orang. Okay, while waiting for the others, nanti you masuk dekat future, check you punya attendance dulu. Sebab baru 17 orang, I think kita bagi masa dulu sampai 10 so that the others can join. Bagi ramai sikit and then kita start class. Okay? Go and check your attendance first.
Okay, Doctor.
Okay. So let's start our class. Assalamualaikum. Today we will going to continue our class with chapter 2, which is unstructured data. Okay, as I mentioned last time, I can't remember last week or during our first class, chapter 2 will be divided into 3 parts. Okay, this unstructured data will have 3 parts. The first one is the NoSQL, which is today we are going to look at the NoSQL database and then the types of NoSQL database. The second part will be how to model the NoSQL, and the third part is the web scraping. Okay, so for today, we are going to look at the first part. And then the first part, at the end of this session, at the end of this class, you should know about the NoSQL database. Okay, and then how this NoSQL database different from the normal SQL database. And then there are 4 types of NoSQL database. Okay, we will look at that. Okay, first, let's look at what is NoSQL database. Okay, NoSQL stands for not only SQL. Okay, it is a non-tabular databases, and it stores data differently compared to our normal RDBMS, the relational database. Okay, and this NoSQL database can come in many varieties of data model. So it based on what type of data you have. Okay, and there are 4 types of NoSQL database, which are the document database. We have the key value pair database, white column database, and also graph database. And the good thing about NoSQL database is it has a flexible schema. Okay, like it's unlike the SQL database where you need to come out with a proper schema so that you will have a good database or a proper database that is that with less redundancy and less mistake, because in normal database we know that each of the entities must have relationship, and you need to make sure that each of the relationship tu betul, kan, macam one to many, and if you have the relationship many to many, how to solve it. Okay, so compared to that relational database, the the normal database, this NoSQL is more flexible, so you don't have to worry about the what we call that about the schema, the structure, the format of your database. Okay, the four types of database that I mentioned before, the NoSQL database. The first one is the document database. So it stores data in the document and similar to JSON. Okay, the JavaScript object notation, and it can contain a pair of field and values. It can be string, it can be numbers, booleans, arrays, objects, and many more. Okay, and the other type of database is a key value database, where it will pair the key and also the value, meaning that your database will have one key and many values. Okay. The third one is a white column, where it stores data in the tables, rows, and also dynamic column. Okay, this white column will have two types. One is a column store, and the other one is a column family store. Okay, the white column is referring to the column family store, where it will have so many columns in the database. Okay. We will see later after this. And then the fourth one is the graph database, where it will store all the data in a graph format, where it has nodes and also edges. Okay, where the nodes will store about the objects, the information about people, the places, the things that you have, while edges is to show the relationship between the nodes. So it's like semantic network that you have learned in ISP610 dulu. Okay, so it's very easy actually, this NoSQL. Okay, this is the differences between SQL and NoSQL, where I got this from the internet. Okay, just a pro and cons for both database. This one, okay, the pros for relational data model, it is easy and easy to use, easy to set up, because you only use the DML, the data manipulation language, and compared to the NoSQL, it is easy to set up. Okay, it's just that the most difficult part is the schema, the design process of the database schema. And the other pros is universal, compatible with many tools, and good at high performance workloads, also good at structured data. But it is time consuming to understand and design the structure of the database, and it can be difficult to scale. Okay. However, for NoSQL, it has no investment to design the model, and it is rapid development cycles, definitely faster compared to the SQL, because it will store the data. We will see how it stores the data. Okay, compared to the SQL, you can have thousands, you can have 100,000s of columns and rows. Okay, so in order for you to retrieve all the data, it will take more times. Okay, and it runs well on the cloud. But however, this NoSQL is unsuited for the interconnected data, and technology is still maturing, and it can have slower response time according to what kind of type of the data of the NoSQL data that you choose. Okay. Okay, this is the differences between NoSQL and SQL according to the criteria. Okay, if you look at the model, the NoSQL is a no relational. However, the SQL is a relational where you need to identify the relationship between one entity and another entity based on what you need to identify and determine the relationship, whether it is one to one, one to many, or many to many. And then for NoSQL, it is stores in JSON documents, key value pairs, white column stores, and a graph like I mentioned just now. However, the SQLs in table. Okay, we have column and also rows. While for data, it is flexible. For NoSQL, and new properties can be added on the fly. The relationship are often captured by denormalizing data and presenting all data for an object in a single record. Good for semi-structured, complex, and nested data. Okay, that is NoSQL. However, for SQL, if you have this kind of unstructured, you have the complex nested data, it's a bit difficult. So you need to really understand, you need to do a lot of things to get the structured data. So susah lah, okay, complex sikit dia punya proses. However, for NoSQL, in terms of schema, it is a dynamic. The schema is dynamic and flexible, but SQL has a strict schema. So in order for you to nak drop table tu, you need to make sure that dia punya connection parent child tu semua kan kena betul-betul tengok which one is the parent, which one is the child punya table, so that baru you boleh buat all the operation kan. So nanti akan ada foreign key, we have the primary key. So, all those things are very difficult tau, nak maintain, nak update, you nak buat everything susah. Okay, in terms of transaction, okay, ACID transaction support varies per solution, but SQL is support the ACID transactions only. And consistencies and availability, okay, you can see the NoSQL eventual to strong consistency supported depending on the solution. However, the SQL is a strong consistency enforced. And in terms of consistency, availability, performance, this NoSQL can be traded to meet the needs of the application. Okay, the consistency is prioritized over availability and also the performance. And then you can see the performance of both database for NoSQL and SQL, and also the scale. Okay, the scale ni is how big your data will be lah. Okay, these are some examples. Okay, one example actually to build a social media website. So there are few I would say requirement. It's not requirement. It's requirement ke? Okay lah, consider it as a requirement. Okay, there are 4. Users can post an article. Can post articles with related media such as pictures, videos, and even music. Okay, so second one is user can comment on posts and give points for ratings. The third one, user can see a feed of posts. And the fourth one, users can interact with the main websites. So let's look at the first one, the first criteria, the first requirements. What are the things, the entity, the relationship that we can identify from this? Okay, the first one, okay, user can post article, meaning that you will have post and also media like pictures, videos, and also music. The second one, comment on posts, and then points for ratings. The third one is about see a feed of post. Ini dia akan ada post kat situ kan, nanti kita tengok. We will see the relational first and then how can we do it in NoSQL. The fourth one is interact with the main websites. So from all this information, you can create an ERD, okay, for relational database. We can see that we have user, we have post, we have comments, we have points, okay, ini bukan ERD. So this is the like macam schema dia tu kan, tengok dia punya relation between each of the entity. Okay, so we have post that is written by the user, and then post will have many comments that is created by the user. Post will have many points, okay, which can be assigned by the user, and then these posts can have many images, many videos, and many audios. So you can imagine from this information, you can come out with a proper ERD, okay, where you will have user, you have posts, comments, points, and also images, videos, and audios. So when it says 1 point, we have many comments, then the relationship will be 1 to many again. And then comments can be created by many users. So one comments by one user can comments can give many comments. So many to one in the relationship. That one is for relational database. Tu contoh. However, in NoSQL database, okay, this is how we model it. Okay, where you can have the ID, where the ID is representing the ID of the post. Okay, it will generate its auto-generated ID, and then we will have also the title of the post, the date, and then the body, what kind of the sentence of the post, okay, and then created by the user. If you have any image, video, or audio, it will display the URL for each type of media that the user posted. Okay, so if you can see, the NoSQL will require only one query. There is no joins at all, and then no schema compared to relational model. Okay, it put everything in one one curly bracket. So it has the ID, the title, the date. So kalau you buat relational schema tu, you will have separate column kan. Ni tak dia store everything in one document. Okay, this is another example. So let's say we have a product where the product has ID, price, and also description. So for SQL, you might have a book, okay, album, jeans, and many more. And maybe, for example, album, it might have another table that relate to the album. Okay. However, for NoSQL, you will have a few documents that will store everything about the product. Okay, one product, you have one document. Okay, then if you have another product, so we will have another document. But in that document, it will store the ID, the price, the description, about the author, title, publication date, and many other things. Okay, so I hope you can differentiate between the SQL and NoSQL now. Memang nampak beza kat situ, okay, because in SQL we need to come out with the tables and nak kena tengok the relationship between one table to another table, like I said, inheritance, everything kan, but NoSQL tak ada issue tu. Okay, now we will look at the 4 types of NoSQL database. We'll start with key value, and then we move to white column. Next, we'll see document database, and lastly is the graph database. Okay, first is key value. So, okay, this key value is a type of non-relational database where it uses a simple key value method to store data. Okay, for one row, it will assign one key. So they pair lah, key and also the value. So when you retrieve the key, you will get the value. So a key value database stores data as a collection of key value pairs in which a key serves as a unique identifier. Okay, so whatever it is, kita akan always refer to the key. Apa dia punya values tu tak kisahlah. Once you retrieve the key, you will get the value. So both keys and value can be anything, ranging from simple object to complex compound objects. Okay, and this key value database are highly partitionable and allow horizontal scaling at scales that other types of databases cannot achieve. So for you to identify which kind of database that is suited for your data, it depends to you punya behavior of your data. So you tengok lah, kalau data you bentuk macam ni, okay, maybe you can store it in the key value pair. Okay, kalau bentuk yang macam ni, you nak buat macam ni, scheme apa, you plan to retrieve sekian, maybe you can use the column the white column punya database. It depends. And each of this type of database ni, dia ada jenis-jenis dia. Contoh for this key value, we have Amazon DynamoDB. Okay, this is how they was the Amazon apa nama dia tadi? Amazon DynamoDB stores the data. So it has the key, okay, and also the value. So kalau tengok kat sini, the first one, product ID and the type. The both combination of product ID and type can be the primary key. Okay, they will use product ID 1, book ID, and then all the values that you want to store. Okay, this is how it looks like. Okay, this is another thing. So you can also put like this. You have the key and also the value. So anything dekat key ni, you boleh ni lah, sama ada auto generated ataupun you can generate the key for your database. Okay, and then the value can be anything in string, JSON format, block, and many more. Okay, key value is the most simplest NoSQL database. Senang je. And then you can use the basic readings command, okay, for reading and writing, where to get the value, you can get key, and then it will return all the values that associated with the provided key. Contoh, if you get key, let's say like get 1, so it will return all the values that is held by key 1. Okay, and put key comma value associated with the value with the key. So now is when we want to put, to append or to store our data into our key value database. So you need to put, you have to make sure that you have key and also the value. So dia akan store lah dekat dalam database tu key apa and value dia apa. Okay, in order for you to get multiple values untuk multiple keys, you boleh buat multi-get. Okay, you can multi-get key 1, key 2, key 3, or any keys that you want to get the values. So list je kat situ by using multi-get. While delete key, where you want to remove the entry for the key from your data store. So based on the key, you will remove the whole thing. The whole thing meaning that the key and also the value. Sama lah macam relational database. It's just that here we only use the key. Okay, dia punya main hero dia adalah key. So anything you pegang dekat key untuk retrieve the data, untuk store the data, untuk get multiple and also to delete the data. Okay, this is very easy. Itu saja untuk key value pair. And the second one is the white column database. Okay, white column. It use all rows and columns. Okay, but it is different compared to relational database. Okay, the names and format of the columns can be varied from row to row in the same table. And also the white column store can be interpreted in the two-dimensional key value store. Okay, tadi kita belajar key value, we have key and also value, but it can be a 2D key value. Okay, tadi 1D je. Okay, kita ada key, kita ada value. But now you can store in a 2D. Okay, contoh macam yang bawah ni. Work by creating collection of one or more key value pairs. So you can have one key and then there are two rows with different columns. Okay. So tengok kat bawah ni, key equals to row ID, value data for key value store. But for white store column, you will have one key with a row ID because we have two rows here. So you need to have the row ID and also column ID. And then baru ada values for the data. Okay, so your key will be the combination of the row and also column. Okay, this is another example where two-dimensional array which has whereby each key has one or more key value pairs attached to it. Okay, this one yang I cakap just now. I cakap tadi kan, column store and column family store. Apa dia column store, apa dia column family store. Okay, for this type of database, column store ni, or sometimes people say columnar database. Okay, where it will store in one column. Everything dia akan store dalam one column, tapi ada banyak row lah. Okay, so dia easy to access. Senang sebab dia macam ada satu column je kan, so the retrieval process will based on the row. But if you have column family store, it means that you will have more than one column. Okay, so retrieval dia tu macam agak cepat, however dia macam lambat sikit lah compared to the single column. Okay, sebab you nak kena tengok column, you nak kena tengok row for the key, and then baru you boleh fetch the data. So there are example for database for column family store. For example, we have big table, we have HBase, we have hypertable and Cassandra. While column base, kita ada Sybase, kita ada C-store, vertical, vector-wise, and many more. Okay. This is another example, okay, for column family store. So kalau you tengok kat sini, dia ada super column family and that will have more than one row and more than one column. Okay, column family ni contoh dia macam address lah. It has the key and it has the value. Okay, so everything ni we considered sebagai white column lah. Is a column family store. Okay. This is example for column store, okay, position based. Macam mana you nak tengok. So kalau if you have the key position based, maknanya ID dia, you akan tengok 1, 2, 3, 4, 5, 6. And then first name, we will look at column by column. So the first column is ID, second column is the first name, third column is last name, fourth phone, and the last one is the email. So it will list all the values for every columns. Dia macam follow, dia akan ikut turutan lah. So if you start with 1, 2, 3, 4, 5, 6, so every values for each column tu dia akan follow sequence tu. Okay, that is position based. And we also have the row based. Okay, maknanya dekat sini kalau you tengok, let's say the key value dia, okay, kalau you tengok 10, and then dia akan match dengan row ID 001, 12, 002, 11, 003, 22, 004. And then 001 is the key for Smith. Okay, dia akan tengoklah Smith is 001, Jones 002, Johnson 003 and Jones 004. Sama juga Joe 001, Mary 002, Kathy 003, Bob 004 and also salary. So dia tahulah kalau kata 001 kalau Smith ni dia tahu dah position dia dekat 001, ataupun kalau dia retrieve 001 it will get 10 Smith, Joe and 40,000. Okay, so it depends what kind of things yang you nak retrieve daripada you punya database tu. But this is how they will store the it will store in white column punya format. Okay, this is column store, row ID base. So for column family pula, okay, kalau tengok kat sini dia akan, we have 4 columns. We have city, pin code, strength and project, and then address and details, okay, are called column families, and then the strength and also the project is considered as a column family address ni considered sebagai the details of the project. Okay, kita boleh pecah jadi dua, column family address and also column family details. Okay, kat sini column family address, it has city and pin code. Column family details, we have strength and projects. So jom tengok how to write this. So kita tengok kat sini, first dia akan cakap tentang the project, where the name of the project, the city and also the pin code. Ni key dia lah. Okay, you will put the key, and then bawah ni adalah details for the project. Okay, kalau tengok kat situ dia ada banyak curly bracket. So we'll start with the first curly bracket and then the key, and then we open another curly bracket for column family address. Okay, and then the details, open another curly bracket to add the details, the strength and also the project, and then we close the curly bracket. Okay, that will represent one row. So if you have, okay, this one is the strength and also the project. If you have 4, tadi kita ada 4 kan? Sorry. Okay, we have 4 rows, meaning that you have 4 keys. Okay, kalau tengok yang the brown square box tu, okay, kita ada 4, so it will represent each row. The first one, second, third and fourth. Okay, we store macam tu. So nanti kalau you buat MongoDB pun kita buat macam gini. Okay, that is white column database. Another one is the document database. Okay, this is another type of NoSQL database designed to store and query data as JSON-like document. So it is easy for the developers where they can store, they can query the database using the same document model format where they can use for their application. And then it is this type of database is very flexible. It is semi-structured, maknanya dia ada structure dia. However, it can be in variety lah. Dia tak adalah macam very structured yang you nak kena follow one by one. But this is semi-structured, dia ada, sekejap lagi kita tengok. Okay, and hierarchical nature of documents and document database allow developer to evolve with application needs. And works well with use cases such as catalogs, user profiles, content management system, where each of the document is unique and evolve over time. So it is very flexible. Okay, ini you boleh tengok CouchDB, Apache Cassandra and also MongoDB. Nanti you all akan buat lah benda ni next week. Okay, so here, okay, you can have a database. For example, macam you ada MongoDB database kan. So MongoDB database can have a collection, and each of the collection might will have the documents. So kalau kita reverse balik, a set of document will form a collection, and a set of collection will form a database. So example of the document macam ni lah yang dalam curly bracket tadi tu, where we will store it in the key value. So you kena ada apa benda and also the value, the key and also the value. Okay. So collection should make sense. For example, books, web store, retail store, fruits, hence document base is unstructured and schemaless. Dia tak ada proper schema. You can store whatever information yang ada. Contoh, one document you have 10 informations dekat dalam tu, ada 10 keys, ada 10 values, but another documents maybe will have only 2 or 3 keys and values. Okay, so dia tak ada masalah. Kalau tak ada pun okay je, sebab dia no rigid schema. So this is a comparison between these two relational schema, relational database and also NoSQL document database, where if you can see it is almost similar. It's just that the terms that we use in NoSQL document database is slightly different compared to normal relational database. Okay, database is sama, but in RDBMS we have tables, but in NoSQL database we have collection. Okay, and in tables we have columns and rows. Okay, rows akan differentiate between one object with another object, while column will representing the features or the criteria of the objects. But in NoSQL, you will have documents where everything you dump into the document. Okay, kat situ ada key and value pair lah. Maknanya you will store everything about the object. Maknanya document ni macam representing satu objek lah kan. Dekat dalam row tu, instead of having columns, dia akan put everything dekat dalam tu. Okay. And then ada index lah. Of course, both of these will have index or ID. And then we can store different schemas in different documents, and these documents reside in same collection. Tadi saya cakap tu kan, one document, another document, even though different format ataupun different schema, you can put it in one collection. So there's no problem at all. So contoh kat sini, the first one we have ID, we have ISBN and also the title. Okay, this is for document 1, and then for document 2 we have ID, we have SE number and also the item. Okay, but you can put it in one collection. So nanti you akan belajar dekat MongoDB tu, you create a database ataupun you can use the existing database, and but you need to create your own new collection that will store many documents in there. Okay, you will find that the MongoDB punya coding tu is much easier compared to kalau you pernah buat Oracle. You pernah belajar Oracle kan? Pernah tak?
Pernah.
You belajar MySQL? Oracle tak ada Oh okay, ada yang kata pernah. SQL?
Pernah.
Okay, good. So you akan nampak benda tu lagi senang. Ini lagi senang. Tak tahu lah. For me, the NoSQL punya nak handling the NoSQL database is much more easier compared to SQL database. Sebab SQL database kan bila you nak retrieve, nak yang macam some of the columns have the relationship. Bila you nak retrieve yang ni, tiba-tiba nanti kan inilah tak kena, itu tak kena. Oh, ni nak kena go through the parent first and then baru you boleh retrieve the child. Banyak benda ini tak ya, you keluar dia punya key and then dia boleh retrieve everything. And you can also have a complete structure. For example, this one, if you have more than one values, you can put it in the square bracket. Okay, this one, if you have more than one value, for example, this one is a book book title. Okay, ID 978 and the title will be the data science. Let's say it has 2 authors, so you just list the authors dalam curly bracket, so dia dah boleh identify dah, bila dia jumpa curly bracket tu, there will be few values dekat dalam tu. Okay, this is another example. Kenapa dia kata bad quality pula ni? Tak boleh dengar ke punya suara?
Boleh.
Dengar.
Boleh. Okay. Okay, this is use case number 1. Okay, content management. Saya document database is a great choice for content semua. Boleh guna. Boleh try buat benda ni. Okay, tapi kena create lah, meaning the values for every contoh macam for the tracks, for blocks, everything tu you kena ni. Tapi boleh imagine lah how to come out with the MongoDB punya code. And then another case study is about catalogs, where you need to identify lah, tengok dia punya e-commerce application, nampak tak dia punya case study. So based on the case studies ni, macam mana you nak come out with a proper you nak design you punya NoSQL. Nanti kita tengok. Okay, boleh baca and then tengok. Try to understand the case studies, and then we can do it later. And then this is the graph database. Okay, graph database is the most simplest one, where you can design to treat the relationship between data as equally important to the data itself, intended to hold data without constricting it to a predefined model, and the data is stored like we first draw it out and showing how each individual entity connects with or is related to others. So you have the entities where the nodes, each of the nodes in your graph database will represent the entity, the objects that you have for your data. And then you will have the connection, meaning that the edges too, they can represent the relationship between one nodes with another nodes. Okay, for example, here we have employee, we have company and the city, and then the relationship between company and employee, the company has CEO, okay, start date when, and then this company located in which city. Okay, so me define social connectivities, and both nodes and relationship have defined properties. Kena ada meaning that you punya nodes pun kena ada properties, you punya relationship pun kena ada properties, sebab the properties will help to describe more about the relationship and then describe more about the nodes that you have in the database graph. Okay, this is the example. You can generate this graph database using Neo4j. Okay, bolehlah nak try nanti kalau you nak try. But for unstructured data, we will only look at MongoDB. Okay, another case study for graph database. We have people, okay, the people who likes this product usually like that product, meaning that we have two products. Okay, people who love the A product product A will also usually like the product B. So Mary is a friend with George. George likes pizza, and George has visited Japan. Thus, we can ask the question of who are the friends of Mary's friend who likes the food that Mary's friend likes but have not visited the place that Mary's friend has visited. Okay, so you are more likely to be friends with Abu because you know Ali since Abu is Ali's friend. You punya connection tu, it can determine whether you ada connection tak dengan the other person. Macam how the Facebook nak recommend the friends kan. Kadang-kadang dia cakap, oh, you might know this person because of you are friend with sekian-sekian orang. Dia pakai inilah network. Okay, network pula dah graph. Okay. So you can try to construct, okay, this use case and come up with your own graph database yang you rasa macam boleh dapat. Maknanya you have ni, you start with this one. Mary is friend with George, so you will have one node for Mary, one node for George. George likes pizza, so another node for pizza. George has visited Japan. Okay, and then you go through satu tu, you come out with the graph. Boleh? Can we do that kind of activity? Dah habis dah slides. Okay, yang atas tadi, yang dokumen apa semua tu, we have to wait for another lecture. This Wednesday punya lecture tu, I'll teach you how to do the the MongoDB punya structure. Okay, but now can you do this? For this case study, kita tengok macam mana rupa bentuk graph yang you dapat. Okay, consider this one. Boleh?
Just
Boleh,
the second one or all of it?
All of it.
All of it, sure. All
But
right.
Okay.
Doctor,
But
I
if
did the second one. So do you mind checking?
Oh, you did the second one? Okay, sure.
Yeah, just the
Maybe you
second
can
one.
share your screen. Yeah, I think this one is like 3 different graph. Okay, the first one you will have people, product A, product B. But the second one too is more more nodes and more relationships. So can you share your screen, Adha?
Now that I think about it, I
Tak
don't
nak?
think I want to. I just did the graph that looks similar to how a semantic net looks. Is that how you do it?
If you don't mind sharing your screen, maybe
Share my screen.
maybe you
Let me
can share
share
the
my
screen
screen
and
because
then
I'm using the browser and not the desktop app. Hold on.
Okay.
Let's see if I can do this. Hold on. Desktop window. Okay. Screen one. Because I thought the task looks similar to how ISP610 did. So
Yes.
I tried doing it the same thing. Can you see my screen now?
Yes. Mary,
Okay, so
apa tu?
I know that the handwriting is horrendous, so I'll walk you through. Mary is friends with George. So Mary, friends with George. George likes pizza, has visited Japan, visited. Thus, we can ask the question of the friends of Mary's friends who likes the food that Mary's friend likes but have not visited the place that Mary's friend has visited. Yeah.
Okay.
So I think I did this.
ABV?
Come again?
George? Friend with.
Friends with Ali.
Friend with.
Yes, yes. Yep.
Abu. Ya Allah,
Abu.
Abu. It looks like ABV.
Sorry. So yes, this is Abu. Yep.
Okay. Yeah. I think this is similar to the semantic net. However, you might have, since the use case is a very simple use case, but I'm sure if you have a complete database for this, you might have more details for relationship and also the nodes.
Yep, exactly.
But currently it looks like semantic net. Memang pun macam semantic net because we have nodes and also edges, and semantic net also have these two component, right? And the nodes in semantic net is referring to the objects, and the edges in semantic net also referring to the relationship between the nodes. Yes, it's similar to that.
Sorry.
Okay.
So is there anything that I should add into this? Is the question?
No.
Nothing for now. Okay. So
thank you for sharing your Answer because I
Alright.
think yeah, dah menjawab dah dia punya.
Alright, thank you.
Okay, thank you Adham. Yeah. Do you have any other question
Actually, I
regarding
do.
Yes. What is it?
Do you mind explaining again the differences between column store and also column family store? Because I think I don't really understand that.
Okay, the column store. Column store actually it will have only one column. Okay, one column with more rows, more than one rows. Okay, but column family it will have um, many columns and many rows, and there will be one key, okay, that will hold the value for column row ID and also column ID. Faham tak? Dia macam dia nak fetch the data. If you want to get the value of that particular row ID and column ID, you need to have that combination. Sebab kalau tidak macam you nak buat, sebab this is NoSQL. Kalau kata SQL, when you do programming, you can do like nested programming kan? Maknanya you pakai I and J, I berapa, J berapa untuk untuk refers to the rows and also column. But for NoSQL, we don't have that kind of structured table. Okay, that's why you need to have a key that will hold row ID and column ID. So by putting the value for row ID and column ID, you will get access to the whole values. So that is the column family. Maknanya column family ni dia consider the combination of many columns and many rows. But column store will refer to one column sahaja. Faham tak? Column store ni dia macam kalau you search, you can Google columnar database. Dia store dalam bentuk column, so dia akan get the key will be the row ID. Since dia ada satu column je, so dia punya key adalah row ID, dia akan call row ID je lah to get the values for apa yang dia nak. But for column family, is a combination of many columns and many rows. Faham tak?
Okay, I think I'm getting it. So I hope you don't mind. I'm sharing the screen. Can you see it? The whiteboard?
Yeah.
Because this is my first time using the browser Teams and not the desktop app.
Okay.
So this is the LinkedIn. Sort of. Okay. So
profile, is it?
And this is for the profile. Okay. So the terms that we are working with is the column store. What am I doing? Column store, column family store, and then super column family store. Is it?
Super column family store is the bigger collection of column family store.
Okay. So the column store would be here, is it? Just here. So let's put this as name.
Column store, yes. One column only, Adha.
Okay, so this is column store. Okay.
Yes.
Just one.
Columns. Okay. It will have two columns. Okay. One row. Mana perlu pula tu? Two columns lah. Okay. ID and also the column, the value. Okay. So it will. In order for us to fetch the data, so you kena pakai the row ID lah. Because we only have one column saja kan yang akan store. Contoh lah kalau you retrieve from where you store you punya script data into one column. So satu column tu je yang akan store the whole thing about the text yang you script from the data kan. So you have to row ID. So let's say you want to fetch the 10 data. So you ambil lah row ID equals to 10. So it will give your the value for the row 10. But for column family, you will have many columns.
Yep.
And each of the column tu akan ada rows. and dia punya store dia tu macam lain, macam boleh sebenarnya different format. Faham tak?
Okay.
Is a collection of that, because sebenarnya when you have more columns, okay, for example macam you tengok kat sini, okay, this one, let's say this is for profile person A, or your profile, and then we have another profile.
What are we looking at? I'm sorry.
Your
Are we still referring to my screen? Oh, okay, to my
yes,
whiteboard.
your
Okay.
whiteboard. Okay, we are referring to, let's say this is the thing that you scrape for your profile from LinkedIn.
Okay, sure.
Your profile will have the first column ni apa?
This one? Or this one?
Yes. Ni yang
This
bawah
is
ni.
the about, this is name, age, and this is experiences. Okay.
Okay. Let's say the about is one data. Okay. Experience is another column lah. You akan ada more columns. And then this is belong to you.
Yes, one user.
Satu column family untuk you. So once you want to retrieve about your name or your age and also your experience, dia akan ada combination of row ID and also column mana yang you nak ambil results tu. Because we have more than one columns. Faham tak?
Yep, I think so.
Because okay, let's look at the SQL database. Okay, kalau SQL database, you have the column and you have the row. So you nak fetch the data dalam let's say like one column yang let's say column 3 and row number 4. So you akan ambil, if bila you buat program tu macam nested kan, you pakai I and J, so I equals to 3, I equals to 3, J equals to 4, then you will get the ni. But itu dalam bentuk structure in a proper table, but now we don't have that table tau. So you store it in a key punya format, maknanya key value format. You punya key sekarang ni adalah row and column. So you just imagine bentuk tu dalam bentuk structure, however we store it in a unstructured punya format. Okay. So once you have the column family, bila dia kata column family, meaning that you will have more columns, definitely more rows. Dia macam collection of column store.
I see. Okay. So this is the hierarchy, more or less. Okay.
Yes. So when you want to retrieve the data for the column family store, you must include not only the row ID, but you must include the column ID also. Because we have more than one columns, and then we need to specify which column that we want to retrieve. So instead of row, you kena specify lah which column. Tadi satu column je, tak apalah pergi pakai row ID je. But now you have more columns for column family.
To make it specific where we want to get the data, because there's a lot of columns here. So need to specify the row and the column for the specific location.
Yes.
Okay.
But because this is for big data, so you can imagine how big the data can be.
Yes. So you're trying to pinpoint that one location, so you need that row and column. Basically the key for that column store.
Yes.
Okay.
So super column family store is a collection. Let's say this is your profile, and then we have another profile that will consist of the same column. So we have like the whole class punya profile from LinkedIn. So it can be a super class family store.
Okay.
So dia ada level dia lah.
I see. Okay. So in this example, this profile is for me and the other profile is for Iqbal. So combining these two together would be a super column family store?
Yes.
Okay.
And you can have more than that.
Okay. So another user here. Okay.
Kan lagi clear because dia macam hierarchy. Apa Iqbal? Iqbal kata apa Iqbal?
Also, thank you Iqbal. Okay.
Actually, this is maybe this is the first time you're looking at this NoSQL database format. So it's a bit difficult, But compared to SQL, this is much more easier. Kan? Because you can store in whatever format you want. But again, depends on the database lah.
Okay. I think I get it. Okay. Thank you so much. All right.
Wih, siap love tu. Siapa love siapa tu?
Ada hal yang Iqbal.
Okay, any other question? I say itu je yang susah nak faham pun. Other than that, macam key value pair is very easy. You have the key, you have the value. Column family, a graph lagilah senang because you have nodes, you have the relationship. Document dengan column family lah, because document and column family ni is almost similar. Okay, nanti kita tengok hari Rabu ni, kita tengok macam mana nak buat document database. Itu seronok sikit. Okay, so if you have no question, betul kan tak ada soalan Tak ada soalan?
No questions as of now. Thank you.
No question. Okay, thank you Adha. Okay, if you have no question, I think that's all for today. Don't forget to take your attendance. Okay, I'll see you this Wednesday. Okay, minggu depan kita tengok MongoDB. Okay, senang je MongoDB ni. I'm sure you all memang sap-soi je. Petik jari je senang. Okay, based on my experience lah, teaching the other groups for previous semesters. Senang je. Kalau you biasa dengan SQL, it is similar to DML, SQL. Entah, senang. Memang sangat senang lah. You tak payah nak create banyak-banyak. Okay. So, okay, I think that's all. Thank you very much. So, but if you have any question, you can always text me. I can explain to you. Thank you, Adha, for asking the question. I'm sure it helps the others too to understand the column family, column store, column family.
Column store, column family, super column family store. All right.
So dia punya ada hierarchy kat situ kan?
Yeah, I can say it now. Okay. Yeah. Yep. All right.
Okay,
no problem.
Thank you.
Anytime.
Bye-bye. Stay safe, everybody.
Bye,
Thank you, doctor. Take care.
Thank you, doctor. And